Can we start now?
Introduce yourself.
This is Sudhir Davluri from Andhra Pradesh in Nellore. Currently, I am pursuing M.Tech in National Institute of Technology, Karnataka, Surathkal in VLSI domain. I completed my B.Tech in JNTU. Apart from this, I completed one offline course in Central Institute of Tool Design, and I done a project on a fast design technique of data multiplayer and quantum dot silver automata and home automation project using FPGA. In my family, I am 2 members. This is all about me.
Okay, so what projects have you done?
In my B.Tech, I done a quantum dot silver automata. In M.Tech, I done home automation project using FPGA board. In the Central Institute of Tool Design, I done a fast design technique of data multiplayer.
Okay, so you have done only one project on VLSI.
Yes, sir. Home automation I done, and track plate controller also I did, but I didn't get in my resume.
Have you done any projects on processor or analog design or Verilog?
And this one is home automation I did here, and in LT space I done CMOS VLSI projects.
Okay, can you tell me the advantage of CMOS over BJT?
CMOS have high density, and it has low power dissipation, and delay also will be less.
How will delay be less in CMOS?
I think so that I don't think that much about the delay, but I know about the delay will be lesser, but I didn't have knowledge about it.
What do you mean by propagation delay?
Propagation delay is the delay which when the input is travel on the way of the to change the output in between of the circuit. It will called as propagation delay, or it is called as critical path delay also. The longest path delay which the signal can travel.
So, what is the dependency of propagation delay on rise time and fall time?
Sir?
What is the dependency of propagation delay on rise time and fall time?
Usually on rise time and fall time. I don't know about it, sir.
What do you mean by switching power?
Switching power, sir. Switching power is done in a dynamic circuits when the input is changing from 0 to 1 or 1 to 0, then the power will dissipate. That is the switching power. It is done when the transition occurs.
Okay, suppose we have to reduce the switching power. So, for reducing switching power, what can we do?
We have so many techniques like clock gating, power gating, and we use sleep network also. By using clock gating, if the transition is not occur, then we stop to, and then we didn't give that clock to that signal. And in power gating, if it is not required power, if it is then if it is not necessary to operate that one, we will use by power gating to stop that one. And by using low VTH and high VTH, that will also, by using that criteria also, we reduce the power by keeping high VTH in high VTH in low critical path and low VTH in high critical path. Like that, we will assign the
Okay.
things.
Suppose we have a setup time valuation in the circuit. So
Okay, sir.
for that purpose, what do we use? Low VT or high VT?
If the setup time is there, means if we have to increase the frequency, we have to decrease the frequency.
First tell me what do you mean by setup time?
Setup time, the data should be stable before the activity of the clock.
Okay, and what are the conditions for setup time?
For the setup time, the data should be stable before the clock. That's why we have to we have an equation like a t greater than or equal to t clock to q plus t clock to q plus a t setup to minus t delay minus t jitter minus t skew minus t jitter.
Okay, what do you mean by setup uncertainty?
Setup uncertainty means if the signal is changed in between of the period of setup time. If the signal is changing in between of period of setup time, then setup violation occurs.
No, I'm talking about setup uncertainty.
Uncertainty, it means metastable state, sir.
No, it's a different thing. Okay, now tell me, suppose we have a setup time violation. So
Okay,
how can we overcome the setup time violation? By using low VT technique.
Low VTH technique. Okay, sir. For setup time, we use for setup time we need more clock delay, and it means we use less frequency. If we need less frequency, then switching speed will be less. Then we need high VTH.
You will need
High VTH. Sir.
why?
If high VTH is there, means low VTH, sir. Low VTH. Low
Okay.
VTH.
Why low VTH?
Low VTH means if VTH is nothing but the transition, the MOSFET should be turned on. If we give the low VTH, then possibility of turning on of the transistor, it should be speed. Then it will increase the frequency.
Okay. First of all, for in setup time violation, if we are violating the setup times, in which in that scenario, there is a condition that setup time violation is occurring. It means that your timing t clock to q plus t combinational is less than
T.
Your the total path delay should be less than the
Yes, sir.
setup
Delay.
window. Okay.
Yes, sir.
So the total clock to Q plus total combinational delay should be less than
T.
T clock plus T skew. So in that scenario, we need to decrease the time. We need to reduce the delay to overcome the setup time violation. Now for reducing the delay of the circuit, what can we do? What can we do?
We use buffer, sir. In buffer, that it will change. It will decrease the transition delay. If it decrease the transition delay, the whole circuit delay will be reduced.
Okay, suppose we have PMOS. We have reduced. We have increased the area of the PMOS. So how it will affect the propagation delay of the circuit?
Again, please, sir.
Suppose we have PMOS, we have reduced the size of the PMOS by reducing its W upon L ratio. So in that scenario, how will it affect the propagation delay of the circuit?
Yes, sir. In PMOS, we generally have it contains low mobility. Because of low mobility, the charging of capacitor it will take so much of time. Due to it, we increase the size of the PMOS. That's why the charging of the capacitor it will take less time. If we decrease the size, then the fast of the then the T delay will be increases. the operation time will be increases.
Propagation delay formula is tau PLH plus tau PHL divided by 2. It means
Yes.
that the rise time from 10 to 90% or fall plus fall time from 90 to 10% divided by 2 is the average of the two numbers defined as the propagation delay of the circuit. Now
Okay.
we have the propagation delay formula. So in that case, uh, suppose we have increased the size of the transistor. So what can we do to how will it affect the propagation delay of the circuit?
We can increase the size of the PMOS transistor or decrease the size of the PMOS transistor.
We are increasing the size of the PMOS transistor.
Increasing size of the PMOS transistor, it will increase the mobility speed. Then it will take the rise time and fall time. It will take very less time. Then the propagation delay will be improved.
Okay. Suppose we have changed the capacitance of the output. We have increased the capacitance of the output. How it will affect the propagation delay?
We increase the capacitance. If we time is equal to RC now, sir. If we increase the capacitance, propagation delay will also increase. I think so, but I didn't have that much of clarity.
So what I was telling that when we increase the size of the transistor, so what happens is that the total resistance depends on rho L upon A. So the area of the transistor is increasing. In that scenario, resistance is decreasing of the circuit. That's why propagation delay of the circuit decreases in that scenario. So now tell me, when does uh, whether it is NMOS or PMOS, acts as a resistor?
PMOS is acts as a resistor.
When does suppose when does CMOS acts as a resistor?
PMOS acts as a resistor.
In which region it will act as a resistance?
In active region, it acts as an amplifier, no, sir.
What are the three regions of MOSFET?
Cutoff region, active region, and saturation region. Cutoff region is takes place when when VGS less than VTH. The active region is takes place when VGS greater than VTH and VDS less than VGS minus VTH. And the saturation region will be takes place at the VGS greater than VTH and VDS greater than or equal to VGS minus VTH.
Okay, so when does NMOS or PMOS will act as a resistance? In which region?
In active region only, sir. In cutoff stage and saturation stage, it will act as switch, on and off switch.
Okay. What do you mean by transconductance?
Transconductance. Transconductance is GM, sir. Transconductance is GM. GM is the inverse of resistance, which is IC by neta VT in BJT.
I'm talking about MOSFET.
Transconductance is GM. Can you please again say the question, sir?
My question is, what do you mean by transconductance in MOSFET? It's very important.
ID by VGS, I think. ID by VGS.
And what will be the VDS?
Sir?
What will be the VDS?
Drain to source voltage.
So in that, when we are calculating transconductance, so what condition should we consider for VDS? It should be constant. While calculating transconductance, VDS value should also be constant along with the rate of change of ID with respect to VGS. Now
Okay,
the
sir.
next what do you mean by figure of merits?
Figure of merit. Figure of merit. I don't had figure of merit.
Okay, so calculate the transconductance of NMOS. How will you calculate the transconductance of NMOS?
Transconductance of NMOS.
What is current when the MOSFET is in triode region?
Triode region, sir. Triode or
Hmm.
uh,
Uh,
in MOSFET triode region is a zero, I think, so, sir. In triode region or cutoff region, both are same only, sir.
Triode region is same as active region. So now you
Active
tell
region.
me,
Okay, sir.
yeah. So what is the equation of current when the MOSFET is in triode region?
Triode region. Mu and cos W by L VGS minus VTH into VDS minus VDS square by 2.
Now calculate the transconductance for triode region.
Mu and cos W by L into VGS minus VTH.
Pardon?
Mu and cos W by L into VGS minus VTH.
Uh, have you wrote it down? Please show me.
Yes, sir.
Uh, how did you calculate it?
VDS square by 2 is constant, no, sir. Let it K as like that, it will be deleted.
Okay. Now suppose you have to calculate. Okay. So now tell me what is the relation between resistance and transconductance?
Resistance is inversely proportional to transconductance, sir.
Okay. So have you studied damping analysis?
Yes, sir.
Suppose you have to design frequency divided by 4 circuit. How will you do it?
What, sir?
Suppose you have to design this design a circuit in which you have to divide the frequency by 4. How will you do it?
Frequency by 4. Then we give two flip-flops with T is equal to 1. Toggle flip-flops when you connected simultaneously it will divide,
Uh,
sir. First
uh,
first T flip-flop it divided by F by 2 and second T flip-flop divided by F by 4.
can you draw the circuit? Okay. Have you studied very long?
Yes, sir.
Okay. What is the predefined value of resistor and wire?
Re- Register value, sir, or wire.
Both. Suppose we have
Wire
an
is wire is a
initializing.
yes, sir. Wire is the default
Uh,
value of and wire is the default value of Z and register is the default value of X, sir.
okay. What do you mean by resistor and wire? What?
Register and wire. Register which will holds the value, wire cannot hold the value. Register wire can wire is used in combination circuit only, whereas register is used in sequential as well as combination circuit also. Wire is a continuous assignment by it contains assigned property, whereas a register it doesn't contains assigned property. And um, wire is in between of two circuits we will connect, sir.
Okay. Yes, suppose we have declared some output as range and we have declared some wire
Okay, sir.
in any Verilog model. Okay. Now when
Okay,
we
sir.
are designing the test bench of that circuit,
Okay,
uh,
sir.
why we use output as wire and input as range?
Because in a test bench we are giving input as we are giving inputs, test inputs to store the value. That's why we are using it as register.
Okay. Have you studied system Verilog?
I didn't study system error blocks, sir.
Okay. Now tell me, uh, what do you mean by full case and parallel case?
In full case, all the assignment if you use in full case, all the statements which kind of like suppose if 2 bits are there 00011011, all the assignments should be assigned. Whereas in parallel case, the assigned value should not be repeated. If it is repeated, it's not a parallel case.
So, okay, suppose we have a input, uh, we have a bitwise input 00, and we have
Okay, sir.
suppose we have a variable whose input is 2 dash b00. Okay. Now suppose we have a second input b is equal to 2 dash b 0x.
Okay,
So
sir.
which value will be preferred and why?
Which will be preferred? In which case, sir?
Uh, suppose when we are analyzing the circuit, uh, uh, suppose we have two values. Okay, a we have initialized 0 0, and
Okay, sir.
we have initialized 0 x.
Okay, sir.
So the value of what will be the value of b in that
It
case?
would be to tick bit be 01 or 00. X is a don't care.
Uh, uh, and suppose we have a variable and its value is 00, and we have again a variable whose value is 0x. Now what will be the value of a?
A value is 2 tick be 00 and A value is 2 tick be 01.
uh,
01, sir, 0x.
0x. We have used that same variable one after another.
Okay,
So
sir.
what will be the final value of a?
Primary value of A is, I think it should be 2 tick be 0x only, sir. It updates the value.
No, no. Its final value will be 0 0.
00 only.
Yeah. Uh, Now you tell me, uh, what do you mean by equal to, double equal to, and triple equal to in very long?
Double equality is used for assign any value. Double equality is used to check that if two operands are there, if two variables are there, like A and B, if it contains 0, 1, the output of double equality is 0, 1, and X. The output of triple equality is 0 and 1 only. The double equal to is represented by uh, uh, triple equality is represented by case equality, and double equality is represented parallel parallel equality. Like I didn't get right now, but double equality when the input is if the one input is X, then it should be output should be X only. Yeah, whereas in triple equality, uh, if the input is and the output should be 0 and 1, whether it will take care all x and z also comparison in triple equality. It is a parallel equality and case equality. Double equality is parallel equality and triple equality is case equality.
Okay. Can we compare don't care condition in case equality?
Yes, sir. We have to compare if the x is also it will compare, sir.
Okay. So, what do you mean by skew?
Skew is the the arrival time between two flip flops. The difference between arrival time between two flip flops is skew.
How can you resolve the problem skew?
By adding buffers.
By adding buffers.
Yes, sir.
Uh, okay. If what do you mean by global skew?
Global skew takes place within the whole circuit. The difference between two arrivals of largest it will depend upon the whole circuit diagram. It will take a difference between two arrival times, the largest arrival time and the smallest arrival time.
So, have you studied H tree, I tree, X tree?
I didn't study, sir, but it is used in clock tree synthesis. I
Okay.
didn't have
So,
that much of knowledge.
okay. Now you tell me. So, what do you mean by clock buffers, and can you differentiate between clock buffers and buffers?
Buffer and buffer. Buffer is used for transferring the signal of same signal, whereas clock buffer is used to reduce the delay. It is used for reduction of delay, transition delay.
Okay. Any other difference? Everything is same in both buffers and clock buffers, except there is one difference.
Yes.
Clock buffers have equal rise time and fall time, and buffers may or may not have equal fall time and rise time. So now tell me, you told me that buffers are used for reducing delay or provide delay. Increase, it is used for to increase delay or to reduce delay. Buffers.
Buffers used for to reduce the delay, sir. It is used to reduce the transition delay. If the transition delay is decreases, then whole the delay will be decreases, sir.
Suppose we have launch flip flop and capture flip flop. In they are connected with wire. Okay.
Okay, sir.
So in between, if I have introduced any buffer, how will it reduce the delay?
Yes, sir. I will say so. Can I draw the diagram?
Okay.
Suppose if you take a long wire, okay, sir.
Hmm. Hmm.
See, sir. Suppose if you take a long wire, then the transition it will take so much of time. It will lose its nature, and the transition delay will be increased by using its buffer. The transition delay is takes to the normal stage, like what it have before state.
So yeah, every circuit has some gates and some circuitry and some modeling. So buffers also have some circuit inside it, some gates. So they are uh, giving delay to the circuit. How will it reduce the propagation? It reduce the delay of the circuit?
I think buffers will affect like this only, but I didn't get your question rightly.
The main problem is if two flip flops are connected with wire, there is a delay of there is delay in between the wire due to
Yes,
capacitance and inductance,
yes, sir.
and
Yes, sir.
also there is some resistance. So
Yes, sir.
there is some RC delay in the circuit.
Yes, sir. Yes.
When we use buffers, the delay
Yes.
of that
Yes.
buffer is much less than that RC delay of the
In,
wire.
in the in the
That's why.
pace of yes, in the pace of resistance, we will keep the buffer. The resistance and capacity of that value also decreases
Uh,
on that
and
place.
and sometimes it happens that when we are providing clock signal to any circuit, after sometimes after some wire delay, it deteriorates.
Yes,
So
sir.
buffers also helps us in reconditioning in conditioning the circuits and
Yes.
amplify our signal so that our original signal could
Hmm.
reach the any flip flop or any circuit in the
Yes.
system. So and uh, have you studied channel length modulation?
Channel, yes, sir.
What do you mean by channel length modulation?
Channel length modulation, it will occur when we kept the gate as constant and we applied the drain voltage. If we increase the VDS, then the reverse bias between the substrate and the drain terminal, if it takes NPN, then it will then it will reverse bias, it will should increase. Can I draw the diagram?
Okay,
Kailash?
okay, try, try.
See, sir. Is it visible, sir?
Yes. So the now explain it.
Uh, when we applied the drain current it contains N terminal, and we applied the positive. Here PN junction, which forms a reverse bias, it will reverse bias will be increased, then the channel length will be decreases like this by applying reverse bias. It is
Okay. The point at which the channel length, the density of Q becomes zero. What is called that point?
peak pinch of voltage.
Okay. Suppose we have to shift our pinch off point towards source. So what will we do for that purpose?
If you want to move the pinch off to source, then we have to increase the drain voltage, sir.
Okay. How will it shift
Yes.
the pinch off point towards source?
Can I draw the diagram actually?
Okay.
Okay, sir. This is the diagram, sir. Okay, sir. Here we are taking as NPN transistor, and then the if you give a gate voltage of 3 volts, suppose if you take the gate voltage as 3 volt, for example, initially we take the gate voltage as 3 volts, and initially we take the drain voltage as 0. Then if you take the VTH as 1 volt to operate the MOSFET, then the gate voltage it needs to be applying 3 volts, and the it's on by 1 volt only, but it contains 2 volts extra. That is the overdrive voltage. That voltage will be appear here, sir. This is the overdrive voltage. That overdrive voltage, it will be here, that is depend upon, firstly it will be same length, same stage in source as well as drain part also. Whereas if we increase VDS, if we increase VDS for 1 volt, as gate voltage as 3 volts, and the difference between VDS is decreases to 2 volts, then here the value should be here decreases to 2 volt, and here the source voltage will be 3 volts only. If we again increases here the drain voltage as 2 volt, then the difference between VDS as 1 volt, then here the 1 volt will be there, but here source will be VGS will be 3 volts only. If we again increases the voltage by 1 volt, if we increase the voltage by, if we increase the voltage by 2 volts, then it will reach the pinch off value. If we again increase to 3 volts, then it will goes to the it means it is away of the pinch off point, and the transistor contains There is no channel in between of drain and source, drain and gate.
Okay. In short channel MOSFET,
Okay.
how will it affect the VT of the MOSFET?
Yes, sir. In short channel effect, there will the channel length modulation will occur. E is equal to V by D. Electric field is equal to VDS by L. As we increase the length, then the electric field will be increased. If electric field increases, mobility will be increases. If mobility is increases, then if mobility is increases, then then the saturation value would be comes fast as forward than before its value.
Okay. So can you write the equation of the charge in while calculating pinch off point? What will be the equation of the charge? Suppose at any point in the MOSFET we have to calculate the value of the charge at any point. How will we calculate it?
Charge, sir. Q is equal to CV. That one, sir. In MOSFET, you want.
I'm talking about MOSFET. And what is the value of the charge at pinch off point?
Charge will be maximum at pinch of points. It
Charge
will
will
reach.
be?
ID will be in saturation at pinch of point. It means Q is equal to IT. As current is in saturation, charge will also directly proportional. Charge will also in high point only.
As you are saying, you yourself drawn the diagram, that the diagram which you have drawn, it's the diagram of the charge in between source and the drain. Now
Yes.
the charge value is itself zero at the pinch off point. How can you
Yes.
say that it's maximum? Its value always zero at the pinch off point.
Yes, sir.
That's why we call that point pinch off point, because charge is becomes zero at that point. Now my question is, as the charge becomes zero at pinch off point, how will the current flow from pinch off point to the source? Pinch off point to the drain. How will the current flow from the pinch off point to the drain?
Yes, sir. There is no channel also, but it contains some. The P substrate is there. Then its reverse bias current will be flows in it, sir. And I think that there is some factors also will affect inside it. It will give the current like reverse bias. Due to reverse bias, it will flow some current, and we increase as VDS is increases. Then the current will also will be increases
No, no.
after.
After that point, as you know that there is a term called drift velocity. So drift
Drift velocity.
velocity, yeah, it's inversely proportional to the charge of the circuit. As charge becomes zero, the drift velocity becomes infinite. So after that point, the charge shoots through that point to the drain at infinite speed. That's how the current flows from that
Can
pinch
you
off point.
can you please say again, sir?
Uh, as there is a term called drift velocity. At
Okay.
that point, drift velocity is inversely proportional to the charge of the layer. So when the charge becomes zero, drift velocity becomes infinite at that point. So the
Yes,
charge shoots at infinite speed from pinch off point to the uh, drain. So in that way, the current flows after the pinch off
yes.
point.
It is also like a short. It is affect like in short channel length modulation only, no, sir. Like it will E is equal to V by
Yes,
that
yes,
that term only it will be included.
yes.
That's one I think I am saying.
Mhm. So that is what about MOSFETs. So, and have you studied the computer architecture?
Computer architecture, I know little bit, sir, but don't know more. But I know like risk and CISC like that. So,
Uh,
somewhat about it.
okay, can you tell me the preference? Can you tell me difference between the risk and CISC?
RISC is the reduced instruction set computer, and CISC is the complex instruction set computer. RISC contains so many variables, whereas CISC contains very less variables. RISC it contains fixed delay, but the fixed delay of every statement, but the CISC contains it doesn't maintain the fixed delay. And risk, the code is very huge. In CISC the code is very less. In risk, the time to complete its action is very speed, and the CISC is very slow. And CISC contains complex instructions, whereas risk contains very small instructions, simple instructions.
Okay. So, which is more suitable for modification? Suppose
For
we have to modify the circuit. We have to reuse the circuit and do some modification in the circuit. So, which one is preferable for that?
I think risk will be preferable, sir.
No, the more appropriate answer will be CISC.
CISC. CISC
Yeah.
is used in a computer, whereas risk is used in mobile phones like that.
Yes.
But if I have one doubt, sir. If in risk we used the every value like which it will assign, but in CISC we didn't have any value. Like in risk we have some finite delay. Then we know that when the statement will occur, when the statement will not occur. But in CISC we have different latencies to execute the program, but it doesn't have any. We unable to see the code when it will come. Is it maintain setup time and hold time variation? But in risk we know whether the values come at that time or not. It means risk is so much preferable, I think. But how, I don't have, but please say, sir.
Actually, the risk structure is so robust that there is
Yes.
a very less chances of any modification. Suppose we can take the example of instruction memory, which is used in the risk. It's only read and write code. So
Okay,
we can't do modification in the read and write code.
It's
And
memory to memory.
yeah, and also 75% of the risk operation are done through load and store operation.
Yes, sir. Yes.
So there is less window in load and store operation for modification. That's why risk is more flexible. Risk is more flexible than.
Okay, sir.
So what do you have studied R-type, J-type, and I-type instruction?
No, sir, I didn't study that. Thanks.
Okay. Have you studied load and store? How does it work?
Load and store. Okay, sir. Can I load? Load means it will, if you take load A comma B, the B will be stored to A.
Okay.
If you suppose like, if store the store A comma B, if you do like that, then A value will be stored to B.
No, it's not like that. Do you know the basic components used in the risk? Basic blocks of risk?
I don't know, sir. Risk structure, risk structure, I don't know.
Okay. No issue. So, what do you mean by? Now tell me, how can you recover from hold time violation?
No, generally hold time violation we can't recover by setting frequency like that. It is takes place in takes, if you want to change, if you want to make hold time requirements, we have to go to PNR status, like placement and routing. There only there is a chance to have a hold time requirements. We have to, if we didn't keep the things in a particular manner, place in a particular domain like that, in which place we have to keep the component perfectly, then there will be a hold time violation. In that we have a chance to reduce hold time violation by keeping buffers. And the equation of hold time violation is T less than or equal to T clock to Q plus T delay minus T skew. we have to maintain this equation in that cell. It will be taken like in placement and routing only.
Okay. Have you, as you mentioned, placement and routing? What do you mean by placement?
We have to keep the cells in a particular manner in a board, in a chip.
What do you mean by
Whereas routing means we have to connect the wires in between of every chip,
okay?
like
What do you
wire.
mean by macros? Have you studied macros?
Macros. I studied, sir, but I didn't have that much of idea. But macros is the instructions type, I think so. But I studied, I'm unable to
Oh,
recall right now, sir.
okay. It's a type of memory block. Memory block. Have you studied uh, crosstalk?
Crosstalk.
Yeah. What about
Okay, sir. When the two frequencies are, when the two different frequencies are there, when we want, in it is according asynchronous, I think so, sir. When we are using two flip flops, we have to get the information. There is a chance of misleading of information if we use two frequencies in asynchronous.
you are telling that there is chance of misleading, but the way you are representing it's so the reason for it is different.
Yes,
So
sir.
crosstalk generally happens when the two wires are so close. There is a capacitance induced between them. So sometimes it's happened that the logic one becomes zero or the logic zero becomes one. It comes in the meta stability set. Uh, that's why generally crosstalk occurs. In that way, you can understand. Have you studied decoupling capacitance?
Decoupling capacity. I didn't study decoupling capacities. Very long.
Pardon?
No, sir. I am preparing for design verification, sir, like Verilog and digital design and STS. Sir.
Oh, have you studied RTL to GDS flow? Do you have knowledge of any?
Open lane. I didn't revise that one, sir, but I completed one project also on open lane.
Okay. Can you tell me in Verilog we used 1 nanosecond upon 1 picosecond time scale? Can you explain it? What is it?
It is a tick time scale unit by precision, sir. First it is one unit, second is precision. Unit means if you take tick time scale 10 nanosecond, 1 picosecond, it means total duration is 10 nanoseconds. It will divided equally 1 picoseconds delay, like scale.
So okay. Now tell me what is the difference between display and monitor? Uh,
Okay, sir. Okay. Display is in the active region, sir, whereas in monitoring is postponed region. Display will display will when display is executed, then the second display value will be executed with another new line. Okay. Another monitor. You are asking about monitor only, sir. Monitor.
yeah.
Monitor will execute the value whenever the value changes. Monitor will execute, and display will be executed. How many times you return, that many times only display will be executed. Whereas if you write two statements of monitor also, it will takes only one monitor value only. If the value changes, that will be changes. In display, the last value will be updated. The current value it should be given. In monitor, the last value, from last value onwards, it will, where the value changes, it will be given the results.
So suppose we have to reduce the clock to Q delay of any circuit. How will you do it?
Clock to queue delay. I don't know about it, sir. I know about the clock to queue delay declaration, but I don't know how to reduce the clock to queue delay.
Okay. Clock to queue delay of the circuit depends upon the charging and discharging of that transistor. So if we increase the output capacitance or we decrease the rise time and fall time of the circuit, in other sense we can say that if we increase the driving strength of the circuit of the flip flop or whatever with the clock we are using, it will decrease the clock.
Okay.
Okay, so I think that is enough for the today.
Okay, sir. What I have to improve, sir?
Uh, I think uh, I don't know about the coding implementation. How how you are good in Verilog coding. If you are not that good much, then
Coding is good only, sir. That much not good, but I will write the codes.
uh, but sometimes it happens that if you are studying the code and you are not practicing it, when the time comes that you have to write it code,
Yes,
there are many errors induced by writing.
yes, sir.
So
Yes.
practice Verilog coding. And also, I suggest you to study the CMOS in more detail from the Weston Harris. There's a book called Weston Harris. You can refer to a Razavi book. Razavi
Rajavi.
book, yeah. Refer to Razavi book. From that book, you study CMOS in more detail, and that will clear all concepts of your CMOS. You
Yes, sir.
you need to little bit uh, to study in more detail CMOS. You know the basic concept, but the depth in which how does it work, you need to little bit work on that.
Okay,
And
sir.
also along that, uh, study also the setup, static timing analysis uh, in more detail. How does to improve the main question, the most important question of static timing analysis is uh, how to improve setup time and hold time. The whole question revolves around that. So you study on each part of that, how to reduce clock to delay, how to reduce combinational delay, how to reduce skew of the circuit, how to reduce jitter of the circuit, how will positive skew impact the delay, how does negative skew impact the delay, what is slack, what is false path. This type of questions are generally asked in the interview. So study that in detail, and then it will be easy for you to crack it.
Okay, sir.
Okay, have a
Sir,
nice day. Uh,
can I have I need the FSM questions or else designing questions where I will get it from, sir? Without GitHub.
you need some FSM questions.
FSM and digital designing questions, sir. Designing questions and FSM question means a million more questions. I
Yeah.
will design million more questions, but infinite series I will design little. I practice only infinite series for a few questions, like 5, 10 like questions like that. I need more questions on it.
You actually you search on geeks for geeks. There will be many questions. Suppose 1010, 1101. There will be 3 to 5 sequence of that Mealy overlapping, Moore overlapping. So both overlapping and lapping case of both Mealy and Moore. Study practice 4 to 5 questions. I think that will be enough. And you design one question and you understand the concept of Verilog coding of one question, then you can design any sequence director if you know the concept of uh, FSM.
Sir,
That's
I have one doubt, sir. You
mm,
know Verilog, sir?
yes.
Verilog. In Verilog, we usually use input register is there, no, sir? Register. In a
Okay.
register, I have yesterday only one that doubt, sir.
Okay.
Um, in If you construct a D flip flop or else SR flip flop,
Okay.
then we use some q less than or equal to q in one equation. In a of the equation like the SR flip flop, the present state will be when is 0 0 input, then
Mm,
q less than or equal to q.
okay.
In a 0 1 it changes to 0, 1 0 it changes to 1. Here if we giving a q as output only, but it acts as input here.
Pardon?
Can I write the code?
Okay, okay, write it down.
Here, if you write this code, sir, for uh, SR flip-flop,
Okay.
here Q less than or equal to Q, no, sir.
Hmm.
We declare Q as output. But
Show it down. Show it down. Show your copy.
my question is, here we represent output as register, but here we are using as input also.
Okay. What is your main question?
It means it will affect the code or not, because we represent it as output only, but we are taking as input, but we didn't declare as bidirectional input, but we declare as output only. If bidirectional, it will be good, but it not declared as bidirectional also.
Okay. You are talking about blocking and non-blocking.
Yes, sir. It is in non-blocking.
Hmm.
It as from my friend says that it's correct or not, I don't know. That's why I'm asking, sir. As my friend says that it will in non-blocking there will be no effect. In blocking there will be effect. Like that he is saying, sir.
Okay. When we use always block, uh, we uh, we can use both blocking and non-blocking assignments, but it depends upon the circuit. So
Yes, sir.
sometimes when we use non-blocking assignments, there may be a situation of race around condition. So in SR flip-flop, we generally have the race around condition. So we use non-blocking assignment in SR flip-flop. Then there may be a situation of race around condition in
There
SR
is a
flip-flop.
condition in array, sir. Yeah.
Yeah, yeah. So if we use non-blocking assignment, so there will be no problem of race around condition in SR.
Okay. Okay, sir.
That's
Thanks.
okay. Okay.